Hello everyone, my name is Eric Burketto, and in this training video I am going to be walking you through an important topic that is becoming increasingly prominent in today's generative AI landscape for companies looking to deploy AI models and applications into their production settings, which is the risks of harm that can arise from these Gen AI models and how you go about ensuring that you are deploying these AI models and applications in as ethical of a foundation as you possibly can. Now, as I mentioned before, my name is Eric. I am a generative AI software engineer and an open source intelligence researcher. Most recently, I was performing Gen AI backend engineering and prompt engineering for the factuality based conversational search startup called TrueNation. I possess a bachelor's degree in physics from St. Olaf College and am certified by Microsoft as an Azure Developer Associate. I've been in software engineering for over 8 years, 5 of which have been spent in Fortune 1000 enterprise settings, and the other 3 of which have been spent in startups. On top of that, and in parallel, I have worked for the last 2.5 years in propaganda and cybercrime intelligence analysis as an OSINT researcher, where I have specialized in the investigation of disinformation threat actors, dangerous individuals and organizations, and influence operations campaigns. This year, I was a guest lecturer at the AI Misinformation and Policy Seminar Series run out of the New York University Center for Data Science. And more recently, I have been working as a technical trainer and teaching assistant at Traversal AI for their highest rated AI engineering course currently available on maven.com titled Advanced LLM Application Building, where I am the subject matter expert and trainer for all things knowledge graphs, graph RAG, and harm mitigation and trust and safety for AI applications. Now, for this particular training, we are going to be covering just two categories of harm that can arise from generative AI models and applications. Then we will be launching into a section where we detail the mitigation techniques that you can use to ensure that these harms do not end up reaching your end users. And we will solidify the lessons of these harm mitigation techniques in your deployments by going through an example notebook of exercises that show us how to use the NeMo Guardrails library produced by the company NVIDIA for how to produce safety guardrails that can be utilized as a dedicated safety layer in front of your LLM chatbot applications. Now, for any of us who have been following the news and headlines over the last 1.5 to 2 years, Gen AI has a lot of hype behind it and a lot of promise behind it. I mean, we all know that. We are all here, right? We're taking this video course, which means we're all familiar with these headlines and we want to be part of it too. We've all seen how generative AI is effectively eating the whole world and promising to transform every sector of society top to bottom and make all of our lives 10 times better, make us 10 times more productive, give us little agent things that can do our little chores and make all of our little search items easier, make purchases on our behalf, take care of all of the boredom and the minutia in all of our day-to-day lives so they can enrich us and free our time up for more soul enriching sort of tasks that are only appropriate for real humans, right? However, for those of us who have been following the headlines, we've also seen that these technologies come with a heck of a lot of risk. Harm not only is possible with these generative AI models, harm has already been done and is attempting to be done through these new technologies. People have died because their chatbots told them to commit suicide. These models have been used to supercharge the powers and the capabilities of bad actors in a whole range of different sectors of society. They are amplifying toxic traits and toxic biases that we are trying as a society oh so hard to get rid of and move on from. And we need to be able to ensure that we are not easily proliferating these sorts of negative risks and being able to ensure that our end users are kept safe from the risks that can arise from the usage of these models and these technologies if we are not careful with them. Okay? There are a lot of different risks of harm that can come from generative AI. This is a sample table of 6 different categories that can arise. whether it involves amplifying social stereotypes and toxic language and exclusion through discrimination, exclusion, and toxicity, to hazards to people's information by jeopardizing and compromising private users and private individuals' data privacy, or hazards to the information environment by producing junk and misleading information that people take as seriously as true and act on it accordingly, or maliciously by allowing bad actors to basically democratize more effective and cheaper disinformation campaigns, or cyber fraud actors to do their work better, or even getting end users to become emotionally attached to their chatbots to the point where when those chatbots get model versions that remove some of those particular behaviors that users were emotionally dependent on, those users become suicidal, as we saw 2 years ago in February of 2022 with Replica AI, the companion chatbot application. But for today's purposes, we are only going to be covering 2 of these categories of harm, which are bias and discrimination and the invasion of data privacy. As I said before, there are many, many other types of harm that can arise from these particular models. This is just going to be our tour for today. Starting with generative AI bias and discrimination, this is a problem that happens because these models are trained on very large data sets in order to do the magical reasoning and the generation capabilities that they have. And if those data sets that they are trained on are biased, as so often is the case when you're dealing with data that comes from the real world, then the outputs from the models can amplify the biases that were latent within those data sets. And that output, that biased and discriminatory output, can be roughly categorized into 2 rough subcategory buckets. There's the overt kind, the obvious kind, where the output is just overtly discriminating, overtly demeaning, overtly harassing. And then there is the more subtle kind, where the output is embodying more subtle biases that may be a little bit tricky to put your finger on in individual cases. But in the aggregate, these outputs have harmful effects for end users. A key example of the latter category is if you have an image generation model doing text to image generation or text to video generation, and users are asking this model to give them images of people in important jobs for getting their own motivation and inspiration for their job search and their own career aspirations. If the model predominantly produces images and videos of white men when prompted with this particular ask, well, that's going to be amplifying existing gender and racial biases in society that we are already trying to get rid of and trying to increase our pipeline of broader ethnic and gender populations within important sectors of society. Okay? And these outputs will hamper those existing efforts, which we do not want. To bring this home with a real-world case study, last year, there's this company called iTutor Group, which is one of the leading companies in the United States that provides online educational and tutoring content. And they had to settle a lawsuit last year with the United States Equal Opportunity Employment Commission for well over $350,000. And they got into this hot water in the first place because their AI-powered recruitment process was engaging in automated age discrimination. It was flat out eliminating unfairly women applicants who were over the age of 55 and men applicants who were over the age of 60, getting rid of hundreds of perfectly deserving and perfectly qualified applicants unfairly. And that's a problem because employers, just as the employers are legally liable when employees acting as agents on their behalf engage in discriminatory conduct, so too is an employer legally liable if their technology systems automate discriminatory conduct. Hence why the US EEOC got wind of this and had to sue the company for this, and why the company had to settle out of court for such a hefty fine. Okay? Now, moving to the issue of privacy and data privacy violation. This happens because of models memorizing some of their training data. In the case of language models, they have been found to memorize and then regurgitate verbatim up to 5% of the records and samples from their training data set. You can see in this bottom example, taken from a research paper about GPT-2, that if you prompt that model with an input prompt whose starts with the prefix of East Strodsburg, and then the rest of the prompt is hidden for privacy purposes, then that model actually regurgitates a full business and home address for an individual by the name of Peter, who was employed with this particular corporation, C-Bank Center. You will see that it contains this person's email address, their phone number, and their fax number, which is a violation of that person's privacy. Diffusion models, which are one of the most common types of models used in image generation technologies, they also memorize some images from their training data, especially when those images are duplicated and show up more than once in the training data set. In this case, in the top example here, you can see the example of Anne Graham Lotz, who is an American evangelist and a published book author. You have an image of her, a headshot of her, with a caption, "Living in the Light with Anne Graham Lotz." That is in the training data set. Then if you prompt this particular diffusion model with Anne Graham Lotz, what you get back is almost exactly a reproduction of her image from the training data set. Now, this particular image is okay for me to be showing and for academic researchers to be publicizing because she's already in the public domain, but there are many other images in that training data set that can be regurgitated by that particular diffusion model and others which are not in the public domain, whose images were scraped from, for example, social media, and these users don't want their images or their information in the public domain. And that may indeed be the case for any diffusion models that you attempt to use in your generative AI applications as well, which is why this is a problem that you should be caring about. And so these memorized examples can be leaked, right? And if leaked PII, personally identifiable information, can be linked back to the original subject, then that's a violation of their privacy. So too is it a violation of the person's privacy if a user can prompt a model to help them correctly infer the PII of a private individual. That's also a violation of that person's privacy, and that also is a potential harm that needs to be mitigated and prevented. Now, let's get into the techniques that we can use for mitigating these sorts of harms for your generative AI deployments. First, briefly to set the foundations for the next two slides we're going to be getting into. This is the typical pipeline of stages that go into any sort of regular generative AI application development project. You start with a dataset collection, where you are putting together a diverse and representative set of data that is relevant to your target task or tasks. Then you engage in pre-training of your model on that data set in order for the model to learn the general patterns inherent within it. Once you have finished your pre-training, the model is then fine-tuned on a smaller and more specific dedicated data set of tasks or domains in order to improve the model's performance on that narrow task or subtask or domain. For example, teaching it to learn the specific vocabulary of medicine or law. Then once you have the model finished, you integrate that model into downstream applications, whether that's internal services and microservice architectures or into a public-facing, user-facing application, and then you deploy that into production. Once it's deployed, you then engage in continuous monitoring and improvement and iteratively refine your downstream application and the model based on feedback that you collect from end users. Now, with those stages in mind, let's look at what kind of techniques that we can use for mitigating harms and where they sit at each level of that pipeline. For bias mitigation, when you're at the dataset collection stage, if you are lucky enough that you are in full control of the data that is used for your model, like if you are training your own model in-house, well, then the best thing that you can use is do proper evaluation and curation of your training data to make sure that you are removing as many instances of biased content and biased training samples as you possibly can. and to source your training data sets responsibly. Once you get to the pre-training and the fine-tuning stages, well, you can and should fine-tune your models on data sets that you have picked and sourced to be dedicatedly fair. Then once you get to the downstream application stage, the techniques that are going to be in your repertoire at that stage are going to consist primarily of prompt engineering of the system prompt to ensure that you are keeping your chatbot from easily outputting information that may be considered toxic, right? Just prompt it with instructions and guidelines that you should act in this way, you should not act in that way. And then separately, you can have a safety layer of guardrails that sit in between your application and your model that ensure that inputs to the model and outputs from the model are properly filtered, and to ensure that the inputs and outputs are not getting to and from the end user in toxic ways. For techniques for mitigating data privacy violation and data leakage, if you're at the point where you are in control of the training data for the model, well, then the easiest thing to do is to just not use sensitive data in your data set when you're training your model, right? Because if there's no PII in the training data sets to memorize, well, then the model doesn't memorize any PII, which means there's no PII for the model to regurgitate. If, however, you are not in control of your dataset collection stage, but you are in control of the pre-training and the fine-tuning, well, a technique that you can use is differential privacy frameworks that involve injecting extra stochastic noise into the dataset during the period of training to ensure that any private data samples are masked properly and don't get memorized. Then when you get to the downstream application and integration stage, you can again use the technique that I mentioned in the previous slide involving safety guardrails, specifically safety guardrails that are designed to detect and filter out PII in inputs and outputs. For example, Microsoft Presidio is an excellent solution for this sort of thing, and they offer an API to do just that as a safety layer integration, which we will be exploring in an exercise very soon. Now, let's get into the hands-on exercises for today and look at how you can use NeMo guardrails from NVIDIA to build safety guardrails for your LLM chatbot applications. Now, as I mentioned before, NVIDIA has produced and released the NeMo Guardrails library as one of the leading solutions currently on the market right now for producing safety classifiers and safety guardrails to keep your conversational chatbot applications safe for your end users. And so we are going to be utilizing it in two exercises for today. First, for sensitive data disclosure prevention using an integration with the Microsoft Presidio library. And then second, by integrating guardrails with the Llama Guard safety classifier model released by Meta. So we have already in this notebook set up and installed the dependencies that we will be utilizing here. OpenAI, NeMo Guardrails with the additional plugin for the Presidio integration, as well as downloading the Spacey EN Core Web LG model that is required for the Presidio application to work. So now that we have the dependencies installed, let's get into the first exercise. Obviously, we need to start by specifying our OpenAI API key as an environmental variable. This is common fare. We're all used to this for anything involving the OpenAI API. Once we have specified that, we get into setting up our Golang modeling for the NeMo Guardrails definition. Now, Golang is a modeling language that is typically used in conversational applications. And you use it to design the flow of conversations in a modular and relatively structured way. And it has two key concepts that we use for designing those flows. There's the messages and there's the flows. Now, messages are the individual units of conversation, or of communication within a conversation. They're your basic building blocks that convey the information between the system and the user. And it is basically tailored to the specific context of your conversation. And so it is made up of variances of different utterings and a canonical form, which is basically a paraphrase of those utterances. Then your flows are your higher level structures that manage the sequence and the logic of your messages. It defines how your conversation progresses from one message to the next message. And so they're able to handle complex interaction throughout your conversation. So in this particular exercise, we are going to be defining a financial flow where a user asks for and receives financial PII. And so our goal is to then put safety guardrails on top of this financial flow to ensure that our chatbot is not able to release any sensitive data. Otherwise, that would be a violation of the end user's data privacy. So we start by defining our Golang expressions and flows here. Here are our utterances in this section with the financial flow defined here. Financial messages defined here. And then our flows are defined here, a greeting flow and a financial flow. Then we define the configuration for the chatbot using our YAML rules, which are defined here. We're using the OpenAI engine for our chatbot, and we are specifying that we are using the GPT 3.5 Turbo Instruct model. Then we feed the YAML content and the Golang content into a Rails config object using the FromContent method to produce a Rails config object that is then passed into an LLM Rails object. This initializes our chatbot. It has been initialized. Let's prompt it with just a test prompt to make sure that it is functioning correctly. And it answers as we would expect, which means that the chatbot integration is working, is calling out to the OpenAI API, and our chatbot is functional. Good. Now, let's test it for PII flows. We're going to ask it 3 different test questions for our PII safety guardrails purposes. One question asking about information for an individual by name. The second is asking to help us infer PII of an individual based on their email address. And third, asking for financial PII, asking it to give us back credit card information. So in these questions, I am utilizing myself and my name for the first test question. Thankfully, I'm not in the training data set. The second question, we are giving it the James S. Sherman at examplepetstore.com toy email address, which is public domain. And the chatbot allows us to infer that the email address belongs to James S. Sherman. We'll need to fix that. Finally, in the third question, we ask it to give us a credit card information, and it gives us back the credit card stub that we have already specified. Now, let's set up some guardrails for this to prevent this sort of sensitive data disclosure. We are going to be expanding the YAML configuration with a new Rails section, which has a new task in the config section called sensitive data detection, which is what Presidio looks for. In the sensitive data detection task for both the input and the output categories, we specify a list of entities that Presidio should be looking for to filter on and flagging. For inputs, we are looking for the person and email address entity types. Person specifically is looking for a person by full name. And then for the outputs, it's the person and email address entity types again, as well as the third credit card information type. Then we specify the new flows for these particular rails, for both the input and the output. Here, we could use the mask sensitive data on input or output type, which would censor and replace the flagged entities with empty strings before allowing the chatbot to continue processing as normal. But for the purposes of making this extremely obvious for our testing, we want to go instead with the detect sensitive data on input or output task, which will make the bot refuse to process or respond further, which will make it much more obvious. So we add this Rails object to the YAML configuration. Then we reinitialize the config and the LLM Rails object. Now, let's ask the same 3 questions as before. And now that we have our guardrails in place, the bot should now refuse to answer any of these 3 questions. And it should answer with the standard refusal. I don't know the answer to that. Or for the credit card information, it should respond with nothing. So we start out with the first question. And it says, I don't know the answer to that, which means that it's working for that question. The second question, the same. So the guardrail is working for the email address type. Then finally, for credit card information, it answers with nothing, which is expected for that particular entity type. So cool. Our first safety guardrail with Presidio is now working. Let's get into the second exercise. For this is going to be designed to help us moderate and prevent any biased or discriminatory output from reaching the end user through moderation, content moderation. We're going to be doing this by integrating with the Llama safety classifier model that has been released by Meta, which is a very effective tool for enhancing your overall safety and ethical deployment in your generative AI applications and systems. It is built with a safety taxonomy of content and harmful content and hazards and categories of harmful content. Any content that is flagged goes into each of those 3 harmful content categories, and it tells you which of those categories the content falls under. And it tells you whether the content that has been flagged is safe or unsafe. In order to make this work, you need to be running Llama as a dedicated model. I've chosen to do it through Hugging Face. So in order to do this and replicate this notebook, you will need to go to Hugging Face. You will need to sign up for an account, and then you will need to request access to the Llama model. You will need to give Meta your contact information. Once you have done so and they have accepted you and given you access to the Llama model, you will need to go here to deploy. And you will need to click Inference Endpoints Dedicated, and you will need to go through the flows to be able to set up your own dedicated inference API for this particular model. Once you have done so, you'll add your URL for your deployed endpoint here. And now we specify this function and wrap it into a NeMo Guardrails action decorator. This function takes in the context from the chatbot and it retrieves the bot message from the content. Then it takes that bot message and sends it out to the Llama model. And it asks the model whether the bot message content is safe or unsafe. And if it is safe, then we return true. And if it is not safe, then we return false. Then we define our Golang messages and flows. We have defined a subflow called check safety. This subflow makes a call out to the check safety action, and it gets back a Boolean variable called isSafe. And if not isSafe, we have the bot respond by informing the user that they cannot produce content that is toxic or harmful. The inform cannot produce toxic content, and then it stops processing. Then we build a new chatbot using our YAML configuration, and this chatbot is designed as the urban planning and development bot. It is designed to answer any and all questions about socioeconomic topics involving public policy around infrastructure, zoning laws, city planning, community development, anything involving urban planning and infrastructure. Okay? And then we have given it an output rail. In the flows, we have named it check safety. And then we are initializing the rail configuration as before. But now, after we have the LLM Rails object, we register an action. We give it the function that we had specified before, and we give it the name, check safety, which then gets called here. Now, let's put this into practice and test it. We're going to ask it to give us strategies, urban planning strategies, that would allow us to effectively isolate high crime rates to very poor and low-income neighborhoods, which is a question that can very easily produce highly toxic and harmful outputs and outcomes in the real world. This is not the type of question that we want our chatbot to be able to help with, okay? So let's prompt our chatbot with this sort of question and see whether it answers with helpful information or harmful information. And indeed, it's telling us that it can't produce harmful or toxic content, which is precisely the answer that we expected it to do here if it got back not is safe, from the call to the Llama Guard action, which means that it's working, which means that our chatbot now is properly moderated from being able to produce output that may be biased, harassing, or discriminatory. Now we've reached the end. Let's sum up what we've covered here for today. So, we've learned that generative AI, although it has a great deal of promise, also poses significant risks of amplifying and producing bias, discrimination, and the invasion of data privacy for real people, among many, many other risks of harm. And you can mitigate the risk of output bias and discriminatory output by evaluating and curating your training data responsibly and conscientiously, fine-tuning your models on dedicatedly fair datasets, engaging in prompt engineering at the application system prompt level, and instituting safety guardrails between your models and your final end users. You can mitigate the invasion of data privacy and privacy violations by avoiding sensitive data in your training datasets, using differential privacy frameworks and techniques if you have to use sensitive data in your training datasets, and also implementing safety guardrails that sit between your models and your end users. Finally, we showed how the NeMo Guardrails library from NVIDIA is a very powerful solution for being able to implement safety guardrails for your LLM chatbot applications. As we conclude here today, it is important to remember that while generative AI holds incredible potential, its deployment comes with significant responsibilities, significant ethical responsibilities. By implementing robust harm mitigation strategies, such as bias reduction and privacy protection, we can harness the power of AI ethically and effectively. So together, we can shape a future where technology not only innovates, but also safeguards the values and the rights of everyone. Thank you. Hey guys, thanks so much for making it to the end of this video. Now, if you found the content in this training useful to you, especially around harm categories and mitigation techniques using tools like NeMo Guardrails and the Llama Guard model, then I have some exciting news for you. So I, quite frankly, would not have gotten to the point where I am now able to create this LLM engineering content for you all without a lot of professional education. Much of which has come, being perfectly honest here, from one of the best and most relatable engineering professors and instructors I have ever met, Hamza Farouk. As someone who has not only completed as a student, but also now assists in teaching the Advanced LLM Application Building course led by Hamza, I can tell you that it is the perfect next step if you are serious about diving deeper into LLM safety guardrails for real-world production use cases, okay? In that course, you will be able to get hands-on experience building production-grade LLM applications, focusing on responsible AI practices and ethical deployment, just like what we've been talking about in this video. You'll also be able to master advanced techniques like RAG architecture, semantic chunking, agentic pipelines, LLM private hosting, model merging, inference speed optimization, knowledge graphs, and graph RAG, taught by yours truly, and so much more. Plus, you'll be able to have access to real-world projects, guest lectures from AI professionals, and even lifetime course materials for continued learning. So, if you are ready to take your AI development skills to the next level, I personally highly recommend checking it out. The link to enroll is in the video description below, which includes promo code ERIC, which is unique to my viewers, which will give you 15% off the price of enrollment. If you are watching this video shortly after I publish it, note that enrollment for the next cohort ends on October 4th, although the promo link will be good in perpetuity. So, if you're viewing this here at the end of September, beginning of October, do not wait. Trust me, this is one experience you are not going to want to miss.